let's establish that gravity exists. There's this thing that causes things to fall towards the center of mass of the Earth, and we call it gravity. And gravity, as far as we can tell, is directly resultant with how much mass an object has. The more mass an object has, more gravity it has. Therefore, Mr. Shute has more gravity than any of you guys, because he has more mass. And the Earth has far more mass than any of us, and so we tend to be pulled towards the center mass of the Earth. Gentlemen, if you want to do that, then you can go back, otherwise you can stay fine. Okay. So, gravity is pulling us, since we're so close to the Earth, towards the center mass, and we stay in our lovely seats, right?
Yeah.
Okay. And when we fall towards the center of Earth, we're accelerated a certain amount, and the certain amount is
9.8 meters per second squared.
9.8 meters per second squared. Now, if the mass of the Earth were higher, would this acceleration be higher, or would it be lower?
Higher.
It would be higher as well. If we're closer to the center of mass, would it be higher or lower?
Higher.
It would be higher, because force gravity happens to be resultant on distance as well. Yes, question?
Is 9.8 meters per second squared the acceleration or the speed?
Well, take a look at the units. It's meters per second squared,
Aha,
not meters
must
per
be
second.
acceleration.
Indeed. So that means that every second that goes by, you're going 9.8 meters per second faster.
Doesn't
So
that,
at 1 second, you'll be going 9.8 meters per second. At 2 seconds, you'll be going 19.6 meters per second.
does that go on endlessly, or is there a limit?
Until you reach this thing called the terminal velocity. Terminal velocity is not the point at which you die or terminate. Terminal velocity is the highest velocity that an object reaches. Now, there's a reason that you reach the highest limit. What causes the velocity to stop increasing? Close.
Aerodynamics?
Yes?
Well, Max.
No? You guys were closer. Yes? It's,
In Newton's law, he said that it'll go on forever unless an unknown force hits.
exactly. So it's caused by an outside force, and it's the F word.
Friction.
It's a frictional force, and this particular one happens to be here on Earth because we have an atmosphere. And so what do we call this frictional force? Not fictional force, but frictional force. What do we call it? We call it air resistance. So air resistance is simply the resistance that air gives an object as the object moves through the air. So as the object moves through the air, which in physics we call a fluid, we have this fluid friction that's resisting our motion, right? Now, which one resists motion to a greater extent? Is it air or is it water? Water. Why water? Because it's denser. There's far more molecules to push out of the way. So that's why boats will never go as fast as planes in general. It's because they are having a greater time pushing that water out of the way than an airplane does pushing the air out of the way. Yes?
What's in between those?
Nothing.
What is
Nothing is nothing.
core? Nothing. What about core?
There's just
Now, remember in chemistry we talked about an atom?
Yeah.
Okay. So in this desktop, how do we know when we've gotten from one atom to another one? What's the outside part of an atom? The electron. So what's keeping one atom from touching another atom? The electrons, because they repel each other. All right.
So what's between those electrons?
So what's between those electrons? Nothing. Unless it's filled in with something.
That makes
Right?
sense.
So when we say that air is less dense than water, which one has more nothing? Air has more nothing.
We breathe nothing.
Yes, question.
Does the air resistance cause the terminal velocity?
Say it again?
Does the air resistance cause the
Yes.
terminal velocity?
Yes, because you take an object and you drop it, right? What's causing it to fall? We said it was gravity. It's being accelerated by gravity, right? So it's called the force of gravity is pulling down. What's pushing up?
Air resistance.
The force of air resistance, right? It's pushing up on it. Now, once those two forces are equal, you're going to reach your terminal velocity. That is, you're not going to accelerate anymore. Now, how do we measure the force of gravity on an object? We'll get to that in just a moment. But first, let's talk about Newton's first law of motion. What's Newton's first law of motion?
An object stays in motion unless acted upon by another object.
Exactly. So, it's an object's going to do what it's been doing. Right? So now it's going to do what it has been doing. So, if it's in motion, it's going to stay in motion. If it's at rest, it's going to stay at rest. Unless, and this is the big caveat, unless it is
Acted upon by an
an outside force. So, if Mr. Schuth found that he pushed off with his rollerblades, he's going to keep on rolling forever, according to Newton. How come Mr. Schuth doesn't keep rolling forever? No. Yes? Maybe. We'll get to that. Friction. What kind of friction?
Well, there's air resistance.
There's air resistance.
And the friction of the wheels.
And there's a rolling friction. Right? Both of those are going to slow me down and stop me. If it's a windy day, air resistance will stop me even sooner. Now, if there is an outside force like a wall, that would certainly stop me a lot faster. But either way, I'm going to stop. Because there's an outside force affecting it. So, it's got to be on the outside. And we'll get to that in a little bit. Question?
But, so, the terminal velocity occurs when the air resistance
We'll get to that
overpowers the force?
when the force of gravity equals the air resistance force. Okay, inertia. Inertia is the name given for Newton's first law. An object rest tends to stay at rest, an object motion tends to stay in motion, and it depends on mass. It's directly related to mass. The more mass an object has, the more inertia it has. So, let's go to the airport, Overthrow. You've been there before. Okay, so you're in your plane, you're flying along, you come down, you land, you refuel, and you're taking off again, right? And you look over to the right, and your stinky brother is on his bike, and he's trying to race you in the airplane, right? Okay? And he put a little motor on the bike so that he could keep up with you. So you're flying down the runway at 100 miles an hour in your plane, getting ready to take off. And he's going down the runway at 100 miles an hour on his bike. Now, which one of you over there has more inertia? The plane, why? Exactly. So it took more force to get it moving, and it would take more force to stop it, right? Okay, so let's do another one over there. Ready?
Okay, sure.
Let's say your brother's practicing for the next race. So you're sitting in your plane on the runway, waiting for the air traffic controller to clear you.
Okay.
And he's on the runway, going down the runway at 100 miles an hour on his bike.
Okay.
All right? Now, in that case, which one of you has more inertia?
The plane.
Why?
Because it's got more mass.
Because it has more mass. So inertia, guys, has nothing to do with whether something is moving or not. It has to do with mass. The more mass it has, the more force it's going to take to either move it or stop it. Remember, force was a push or a pull. Does that make sense?
Yeah.
Okay. So motion does not matter with inertia. So, second law.
Who entered the second law?
Second law, several guys already said it.
The relationship between an object's mass and its acceleration it's applied to F is F equals ma.
Good.
Acceleration.
So, let's see. So, it's the relationship between, what does it take to accelerate an object? What's the relationship between its force and its mass? The more mass it has, the more force it takes to accelerate the same. If you're going to use the same force on an object, the more mass it has, the less it's going to accelerate. So, if Bisha were to push a semi-truck and then a go-kart, she's going to be able to accelerate the go-kart more than the semi-truck. Right? Because the semi-truck has more mass. Now, take a look at this. If this is mass times acceleration, let's go backwards. We've already done this, right? Because distance, not working. There we go. So distance, we said, was measured in what unit? Meters. Now, if we did rate of change in distance, then we would call it speed or rate, right? Yeah. I like speed better because it's more specific than rate, because there's all kinds of rates. Speed would be meters per second, i.e., how many meters do we go for every second that goes by? Acceleration is the rate of change of speed, of velocity, right? Acceleration. So we find that it is meters per second because that's speed, and how fast does that change? It's meters per second, or we could rewrite it as meters per second squared, right? Now we have something using acceleration and mass. Since F equals ma, we find that it is kilograms times meters per second squared. So all we've done is we've taken acceleration and added kilograms. And as I said before, you got to know your basics before you can go on and keep adding things to it. I said we're going to start with the basics and get them down. Write the formula. Fill in the unit. Follow the units. Get the units right. Because we're going to keep adding. So, force is measured in kilogram meters per second squared. And the other word for that is what? A Newton. So force is measured in newtons, and that's kilogram meters per second squared. Okay?
Okay.
Alright. Sure, let's try one, shall we?
Sure, why not?
Okay. Alright. So,
Alex, what's that song called? I'm gonna look it up on YouTube.
so let's say we take, let's say we want to know what the acceleration is on Mr. Schuth.
He's riding a cow.
Let's say Mr. Schuth is going to get an award for Best Teacher of the Year at Sycamore School or the universe, and David Bishop and Alex Dahl are pushing him down the aisle so he can accept the award because he's so modest, right? And Mr. Bishop, Mr. Dahl, each pushed Mr. Schuth down the aisle with a force of 100 newtons. So what's the overall force that Mr. Schuth experiences? 200 newtons. So he experiences a force 200 newtons down the aisle, and Mr. Schuth has a mass of roughly 85 kilograms with his clothes on. And hopefully he has his clothes on. So what we find, 200 by 85, what's that?
2.4 something.
Okay, 2.4 something. So 2.4 something, and then what are the units involved? This is the real question here. Yes, sir.
2.35.
2.35 newtons per kilogram.
Newtons per kilogram. Absolutely. Now, Mr. Schuth can accept, excuse me, I'm still doing that all these years later, can accept this. It starts now, boys, and it never stops for some of us. Some of us, what happens is you're just talking along and you're talking like this the rest of your life. Some of us crack all the rest of our lives. And if you find that you're cracking and you're not stopping, it's going to happen the rest of your life. All right. But you have to remember, guys, a Newton is kilogram meters per second squared. And if you put it over kilograms, what factors out?
Kilograms.
The kilograms factors out. You're left with meters per second squared, which is Acceleration, what we're looking for. So, follow the units. Do they make sense? Do they not make sense? Okay? Majuri, question.
Wait, so n equals